Sugar gets such a bad rap, right? We're always told to cut back on it. But what if I told you it's the one thing your brain absolutely cannot live without? Yeah, for real. So let's get into it and break down why your body is actually so hooked on it. So you hear sugar and you probably think bad. But our bodies, they are completely, totally dependent on it. So the big question is, why, right? Why is this one little molecule so critical for our very survival?
Well, the answer is surprisingly simple, and it's really the main character of our story today. It's because your brain demands it. That's it. Everything else we're going to talk about in this explainer, it all comes back to that one single crucial fact.
Okay, so let's start with the brain itself. This is our body's command center, right? Incredibly powerful. But it's also, and this is kind of funny, surprisingly picky when it comes to what it eats for energy. And when I say picky, I mean really picky. You can just think of the brain as a super picky eater. It's not going to snack on just any old energy source floating around in your bloodstream. Nope, it has a very, very strong preference for one specific thing on the menu. So just how picky are we talking? Well, think of it this way. Glucose gets the all-access VIP backstage pass. It gets in directly, no questions asked. Then you've got other fuels, like ketones. They're kind of like the backup plan, only allowed in when glucose is super scarce, which, by the way, is the whole idea behind keto diets. And then you've got fatty acids. For them, it's a hard access denied. The door is slammed shut. And that just makes you wonder, right? Why? Why is access denied to a perfectly good fuel, like fatty acids? The rest of your body can use them just fine, so what's the deal with the brain? Well, the answer is this incredible piece of biological engineering called the blood-brain barrier. Seriously, think of it like the bouncer at the most exclusive club in the world, or maybe a high-security checkpoint at a top-secret facility. It's this super selective membrane that decides exactly what gets in and what stays out. And fatty acids, they just don't have the security clearance. So here's the bottom line. This barrier is amazing for protecting the brain, but it also really limits its fuel choices, which makes a steady supply of glucose absolutely non-negotiable. Okay, so if the brain is that dependent on glucose, what happens when the tank starts to run low? You'd think that would be a catastrophe, right? Well, not exactly. That's when the body's incredible emergency plan kicks into high gear. And the body doesn't just panic, oh no. It has a very precise, very calm protocol. The second those glucose levels start to dip, the brain sounds the alarm. Immediately, a team of hormones gets dispatched with a single target in mind, the liver. And the liver's orders? Deploy the sugar reserves now. It's like a rapid, military-style operation happening inside you. And look, this isn't just that vague, I'm feeling a little hungry kind of feeling. No way. The brain's alarm signal is a highly specific message sent through an incredibly sophisticated command chain. You can think of it as an executive order coming straight from the top. So where does this executive order go? Well, it starts in a part of the brain called the hypothalamus. From there, it travels lightning fast through what's called the autonomic nervous system, which is basically the body's internal wiring, and it zaps two very specific targets, the pancreas and the adrenal glands. And once that signal hits those glands, boom, they release the hormonal first responders. So let's meet the team, shall we? You've got glucagon, you've got epinephrine, which you probably know better as adrenaline, and you've got cortisol. These are the chemical messengers that are sent out to fix the problem, and they have to do it fast. Now, these hormones are carrying a single, very urgent message, and they're delivering it straight to the body's strategic fuel reserve, the liver. The liver's amazing. It's basically your body's pantry and its power plant, all rolled into one. And it has just received its marching orders. So what are those orders? Well, the liver can launch two different, totally incredible rescue missions. Mission number 1 is called glycogenolysis. That's the quick fix. It just starts breaking down the glucose it already has stored up. But then there's mission number 2, gluconeogenesis. This is more of a long-term solution. It's a much more complex process of literally creating brand new glucose from other sources. It just goes to show you, the body is prepared for pretty much any situation. So, okay, when you step back and put all these pieces together, what do you have? You have something pretty incredible, a personal bodyguard system for your brain. So let's just recap why this is so vital.
There's a line from the source material that just nails it. It sums up the whole thing perfectly. It says, when glucose in the plasma drops, the brain sends instructions to restore plasma glucose. It's that simple. It's a direct cause and effect, a closed loop, all initiated by the brain for the brain.
And really, that's the big takeaway here. This entire chain of events we just walked through, from the brain sensing a tiny dip in fuel, all the way to the liver manufacturing new sugar, it's one big, sophisticated bodyguard system. And its one and only job? Protect and fuel the brain at all costs. No matter what's going on, the body will always prioritize its command center.
It's just an amazing, totally life-preserving system when you think about it. And it really makes you wonder, doesn't it? I mean, this is just the system for managing fuel. What other incredible, hidden systems are constantly working away in the background, all with one mission: to protect your brain?